Mark. All right. In case you don't know who I am, I've been in the standards community, in the H7 community for a good long time, and have been doing FHIR since before it was FHIR. Hopefully, many of you have seen me on chat.phir.org or elsewhere. And if you haven't, then get on chat.phir.org and I can meet you. My objectives for today are relatively simple. We're going to go through a quick survey of what the different options are for sharing information with FHIR, and there's probably more than you thought there were. And then we're going to talk about how do you figure out amongst all of those possibilities what is the best way to meet your particular use case and leverage FHIR in a way that's going to maximize interoperability and maximize the benefits that you get out of it. This slide deck and most of the presentations that I give are licensed under Creative Commons, so you are free to download and use the content within your own organization, etc. Just say thanks to HL7, maybe to me. This presentation is actually a follow-on from one that I did last year. I think the title was Flicker Bonfire, and that sort of talked about good practices in terms of how to go about using FHIR and things to think about when using FHIR. And if you didn't see that one, you might want to take a look at that as well. That link is not to the slide deck. I think it's to the video, so you can hear the words too. This work and what I'm going to share with you came about and was funded by, so thanks for that, the Davinci Project, which is one of the accelerator projects within HL7, leveraging FHIR to promote the needs of a particular business area, in this case, the needs of the payer space, and particularly US-centric, although the work that we're going to share today is not US-centric at all. Davinci has kind of gone crazy. They've produced over 20 implementation guides in the span of just over 2 years, and several of those are now approaching final publication. But they found, despite the fact that they had a sort of coordinated set of organizations and an overarching steering division and that kind of thing, that the implementation guides were choosing different approaches for data sharing. And it wasn't always clear why. Either maybe they should have been using the same approaches, or if there were good reasons for them using different approaches, it was hard to express and communicate why those differences were the way that they were. And when we go to ballot and we're going to ask, more importantly, the implementer community to roll out our specifications in production, we needed to have a better explanation than we decided to do it that way. We needed to provide some support for our design choices. And so driven from that, we did a fair bit of investigation and analysis and review of what are all of the options, what are the different ways that you can share, and what are the reasons that might cause you to choose amongst those. And there's actually a whole lot. When people think about FHIR, they often think first and foremost about REST, but even within REST, there are numerous approaches. Are you going to post or put your data to create it or to update it? Are you going to use batch? Are you going to use transaction? Are you going to use search? All of those are completely RESTful, but there are different ramifications to using them. And then there's a whole bunch of not so RESTful mechanisms and messaging and documents and operations and things like that as well. And you need to figure out, well, first of all, you need to be aware that all of those options exist. And the core specification doesn't necessarily jump out and say, here's all of your choices. And then once you're aware of what all your options are, you need to choose among them. And there's various ways to approach that. From my talk last year, one of the key design principles that I think exists in FHIR is that you should try to minimize the long-term costs to the community. That's a should, not a shall. And there are certainly people who will choose to not make that their most important objective. But in the end, if we want to maximize the amount of interoperability that's happening, making it as cheap and easy for the community at large to do that is beneficial. And that means that we want whatever we roll out, whatever interfaces we enable, to ideally be reusable and multi-purpose, so that we don't roll out an interface that's only good for one possible thing, and that as soon as there's another use case, you need to roll out something different. And the second is to look at what is the community actually doing. So there are capabilities that are defined in the FHIR specification. For example, doing Sparkle queries against RDS data, that yes, that exists, and yes, that's been demonstrated, and yes, that is in production in a place or two, at least I think, or it's at least been demonstrated at Connectathon. But you're not going to find a whole lot of solutions out there that do that. And sometimes that's just because it's an edge case technology that isn't well understood or doesn't add significant value. Sometimes it's because it's hard. And it's not something that you can take an existing backend and easily build an interface that supports that exchange approach on top of it. And therefore it tends not to be done very much. But in either case, either because it's niche or because it's hard, you might want to think carefully about whether you want to pursue that as the approach that you choose in your space. If we think about the notion of reusable, with REST, if you wanted to do a put of encounter, that same interaction, that same fundamental capability can be used to do a whole bunch of different things. So maybe you're transferring the patient from one bed to another. Maybe you're capturing the location of their valuables. Maybe you are prepping them for discharge. All of those are represented in FHIR as just a put on the encounter endpoint for a particular resource ID. And if we compare that to a messaging approach, you will typically find that REST gives you more reusability because it's completely use case agnostic. We're just changing this resource. We don't know why we're changing it. We don't care why we're changing it. It's just a simple update. Now that's foreign to certain implementation environments where their whole approach to security and approach to management of who's allowed to do what is driven by having tightly constrained functions. And so just challenges with having multi-purpose. But the benefit of multi-purpose is that you don't have to create and negotiate and map and quite often custom code a new operation or a new message definition. Whereas if you go with some of the other exchange approaches, you do have to negotiate those things because exactly what data gets packaged up inside of the message bundle, exactly what event codes are going to be used, exactly what responses are permitted, exactly how information is going to be organized inside the document. All of that is not nailed down by the FHIR core specification and can't be because the core specification in FHIR is intended to be use case agnostic. And as soon as you start looking at documents or messages, then you tend to be pretty use case specific. It doesn't have to be that way. You can have messages, you can have operations that are pretty generic. So for example, the patient everything operation can be used for a whole lot of different purposes. it gives you a dump of all of the data that exists for this particular patient, and you can consume it for research, or you can consume it for payer analysis or all sorts of other purposes. But in general, some of the mechanisms for Exchange and FHIR are going to be more generic and more reusable than others. And even if you choose to go with something like messaging or documents or operations that are typically less reusable, at least think about how do you maximize the reuse of them in the design, rather than creating something that's super narrowly scoped for your particular space. In terms of wide adoption, part of it, in addition to how widely spread is the technology, it's also a question of how much of it do you have to do in order to be interoperable and in order to be conformant. One of the powerful things about RESTful search is that you don't have to support all of the different mechanisms, all of the different search criteria, all of the different modifiers in order to comply. And so that makes it pretty easy for a system to say, these are the things that I index on, these are the joins that are relatively straightforward and efficient for me to do. And so I will expose in my capability statement, this is the pieces of search that I support, and they can be compliant, and somebody else can support slightly different sets and also be conformant. Obviously, that doesn't mean you get full interoperability. Obviously, if every server supports different combinations of search parameters, your ability to exchange things as easily is less, but it lets people build. So you start by exposing, these are the things that are easy for me to do, and so I'll just expose those by default. And then you can negotiate adding one or two more things to your interface based on the needs of a particular use case. On the other hand, something like _filter, which is actually part of the search API in FHIR, adds on a whole query language. And there is not a conformance layer defined in that language that lets you say, well, this is a level of nesting of ands and ors that I support, or these are the particular comparison operations that I support and I don't support the others. So it's more of an all or nothing kind of thing. And because of that, it tends not to be adopted, or at least not adopted as widely. If you are building a system that is FHIR from the ground up, then it's not so hard. But even there, the reference implementations took a while to adopt it. And if you've got a legacy backend, then it can be challenging. So those are some general principles that apply sort of regardless of which of the exchange mechanisms you're looking at. But beyond that, Davinci went a little bit beyond that, and they put together a decision tree that walked through that complete list. So there's a table that asserts for each of the different exchange mechanisms which of those things are typically widely used or not so much, and which of them tend to produce solutions that are reusable and use case independent, versus the ones that tend to be pretty narrowly scoped. And so you can look at that, but then you can also look at this decision tree. And this implementation guide has not yet gone to formal publishing. We actually just took it back to ballot in the September cycle, but we're hoping to publish it probably February-ish. We'll see how reconciliation goes. And the intention is that this content will show up in the official FHIR spec in R5, but that's still a year and a half away-ish. And we wanted to make sure that it was available to the community sooner. So you can't read that, I can't read that. So let's zoom it in a little bit. And this is not a sort of a conformance thing where you must adhere to this decision tree. And if you don't follow the guidance that's provided here, we're going to declare you as not FHIR conformant. It's more of an informative, here's some good things to think about, and an approach that we think is useful in evaluating the different ways that you can share information in FHIR. And the way it works is there's a whole bunch of different questions that it asks you. The questions that you see on the screen are, of course, really simple, and that doesn't give you much context. But if you click on that link, it'll take you to a paragraph or 2 or 3 or 5 paragraphs, depending on what the decision point happens to be, that fleshes out the nuances of that particular consideration, and then directs you either to another decision point, or in some cases directs you to a particular exchange mechanism. And then you can click on the link, for example, communication request or CDS hooks or GraphQL or whatever, to go and explore what does that mean, and then to go from there directly into the relevant section of the course specification, or in the case of something like CDS hooks, into a separate specification, because not all of these are documented in the course specification. That doesn't mean that the content that's in the HRX implementation guide is the only thing that you're going to need to pay attention to. You will be driven by legacy. So if you have a messaging backend and you don't have identifiers for a lot of the business objects that you want to expose, and you don't have history and some other kinds of things, then that limits your options. And that's reality, and that's okay. There's a reason why we support messaging and documents and some of those other things. You may have existing infrastructure you want to continue to leverage. So if you are an XDS shop and already do all of your sharing using documents, then exposing FHIR over documents may be at least a logical incremental step before you start looking at a RESTful interface or something like that. And of course, you will have architects who strongly adhere to particular exchange mechanisms, and you'll need to do that. Really important consideration is, who are you planning to share information with, and what do they support? If you're talking about EHRs, there seems to be a strong bias towards RESTful APIs, in part because it makes life easier for the EHR vendor to have a context-independent, use case-independent API that they don't have to worry about changing and creating new interfaces every time somebody comes up with a new use case. But that's not necessarily going to be true in all areas. And so you'll want to explore those things as well. Going to start walking through, first of all, a quick overview of the options, and then some of the key considerations from the document. And then we'll have a chance for questions and maybe do some more detailed exploration of the document after that. So how can you share stuff? The simplest way for sharing is to do a read. So you already know what record it is that you want because it's been pointed to by something else. And so you just go retrieve it. But there's a number of different variations on that RESTful GET type mechanism. So you can do full searches. You can have a batch that combines a bunch of searches. You can retrieve a specific version or a history of all of the changes of a particular resource or set of resources. As mentioned, we have the filter mechanism, which adds an additional, more capable query language on top of base RESTful query that includes multiple nested layers of ands and ors and that kind of stuff. There's underscore query, where you're essentially defining a custom operation that behaves like a search and can be combined with other search parameters. And that's not one I've seen implemented terribly widely, but it's available. We have a completely custom language called CQL that allows you to not only query multiple resources, but to manipulate them. And rather than returning a full-blown resource, to return individual data elements or perform logic to assess and extract information from those and transform information from those. We also have things that don't use yet. You can use tasks to say, hey, other system, can you please give me information that looks like this? And then sit and monitor and watch them say yes or no, and eventually give you responses and then say that they're done. And there are situations where having that asynchronous and potentially humans involved makes sense. We have communication requests where you can create a formal authorization for data sharing. So for example, I authorize and actually ask for you to share my lab results with provider XYZ and having that as a formal authorization sitting on file. And we have custom operations that can do pretty much anything you can imagine. And we have messaging, which can also do pretty much anything you can imagine. Operations typically invoked RESTfully, messaging adding on to that, routing capabilities, and some perhaps easier packaging of information so you can send a whole lot of data at once. If you're not wanting to retrieve full-blown resources, we also have CDS hooks where you are essentially injecting decision support. And as activity is happening, you're providing cards to say, you're not necessarily right now following opioid protocols, or the drug that you're trying to prescribe isn't covered, or the lab test that you're trying to order was already done yesterday. Are you sure you want another one? Presumably on a lab test where doing them daily is not necessarily a common thing. We've had some presentations today around GraphQL. That's an option. Sparkle, if you have an RDF interface, CQL can be used not only to retrieve full-blown resources, but individual data elements. And operations and messaging shows up here as well, because operations and messaging can do pretty much anything. If rather than wanting to pull resources where the data consumer, the system that wants the data, is deciding what is going to flow, but instead you've got push, where the source of the data, the system that owns the data, is deciding what's going to flow. We have consumer directed. So the system that wants the data is deciding in general what it wants, but it's up to the data source to determine when that happens. So you can either poll to monitor for when new records come into play, or you can subscribe and say, hey, I'm interested in receiving encounters for patient XYZ. Please send me any that show up. And then when they happen, they get pushed out, either with the data included directly, or just a notification that says, hey, the subscription that you created, there's new stuff, come check. And then you use one of the other mechanisms to go and retrieve that data. And then we also have source directed, where the data consumer doesn't really have any choice about what comes to it or when. It can decide whether it wants to accept it or not. But I can create data on your system using either a post or a put, create or an update. Or I can send you a batch, send you a whole bunch of stuff at once, or a transaction where you have to process it as a single unit of work. Or I can use patch. So rather than sending you the entire patient resource, I'm just going to send you the particular phone number that changed and tell you it's phone number 3 in the current version, and then you can go and update that without me sending you everything. Or you can package up your data in various ways, either for human readability as a document, or just an arbitrary collection. We have a bundle resource that supports either of those. And again, operation and message shows up there. So there's a pretty significant set of possibilities for data sharing, and this doesn't include things that are defined outside of HL7. So there has been work on SQL on FHIR that has not yet come into the HL7 standards process, and we didn't try to tackle those kinds of things. And there will be more kinds of specifications that show up. This also doesn't yet talk about smart web messaging, and presumably that will end up needing to be in the list too. And these are things that you therefore need to explore or should explore when you're looking at the possibility of doing data sharing. So let's talk briefly about some of the decision points. The first one is pull versus push. And that's really a question of who is in charge of when does the data flow. In a pull scenario, the data consumer, the system that wants the data, decides when it's going to flow, because they are either initiating the process or they are at least don't have control over the availability of the data. So from the purposes of this document, polling is still treated as a push, in that the fact that a new encounter got created is not in the control of the data source. They just keep saying, is there anything new? Is there anything new? Is there anything new? And occasionally stuff shows up. That would still be considered a push because it's the data source's determination that, hey, yes, there is something that's going to be shared right now. And quite often, the driver for pull versus push is who gets to decide what happens. If somebody is pushing data to your system, then they kind of have the ability to decide what's going on. And sometimes that's the natural relationship and sometimes it's not. Polling and subscription is a slight variation on that, in that the sender has a bit more control over what it is that's going to come to them. Whereas with a batch or a transaction or whatever, you have the right to say no. But if you say yes, then there is an expectation that you are creating that record at that particular endpoint with that particular ID, and that it will be available henceforth at that location. It's not a situation of I query for data and I look at it and I decide if I'm going to store it and where I'm going to store it and how I'm going to store it. There's a different relationship there. Do humans need to be involved, or is there some sort of special processing that needs to be involved in the data that's being returned? Ideally, in healthcare, we don't have humans because humans are unreliable and expensive and slow. But there are lots of situations where in healthcare they're still necessary. So if I'm asking for data, particularly with my Davinci hat on as a payer, and let's say I want justification for a particular claim or a prior authorization, I can say I want authorization for this, but I don't have a clue where in the electronic health record that authorization might live. Maybe it's a lab report, maybe it's an assessment of some sort, maybe it's in a PDF document. It could be all sorts of different places. And I probably don't have permission to go wading through all of the patient's data in the EHR looking for information that might support a particular claim or prior authorization. And B, even if I did have that authorization, I don't have the time because it would probably require a human being doing all of that searching on my end. And it's much more efficient to ask a human being on the clinical system side, whether that's a doctor or administrator, but somebody who knows the system and knows the patient, and say, what's the reason for doing this MRI? Because they're going to be able to, they know the reason that they did it, and they will have a much better idea where in their system to find that and get that back to me. There are also situations where there isn't trust. So I might want to receive information, but the system that I'm accessing doesn't necessarily trust me to go and query and retrieve whatever it is that comes as a result of that query automatically. And so there's a desire for a layer to be there that even if I can specify the specific resource and the filters and whatever that govern what it is that I want back, that there's that ability to intervene and have somebody take a look at their search response and take a look at the request and say, yeah, that's reasonable. It's okay for you to have that. Or it's okay for you to have most of that, but I'm going to strip out these two results from the search, and I'm going to trim out these data elements because you shouldn't see those. And that's a situation where something like task or communication requests might make more sense. As I mentioned earlier, sometimes what you want back is full-blown resources. So encounters or allergy intolerance instances or conditions or whatever. Sometimes you want back 5 or yes or true or something like that. Or a collection or an array of numbers, but not necessarily tons and tons and tons of resources. And different mechanisms in FHIR have different capabilities. A lot of the widely implemented capabilities in FHIR will always return full-blown resources, but technologies like CQL and GraphQL and Sparkle and custom operations can bring back individual data elements. So something like I want an average or something like that. We have an operation on observation that can bring you back statistical measures. It actually returns those as observations at the moment, but they are generated observations as opposed to pre-existing ones. As I mentioned previously, with push, there is the notion of push being consumer configured. So the consumer, the data consumer has control over what it is that's coming back, meaning that you're using polling, you're using subscription, or the consumer has no control. I'm going to send you a batch or a post or a put or a transaction, and what is going to happen, the fact that it is a create as opposed to an update is not in your control. If I send you a post, you can't easily treat that as an update. There are some mechanisms where you might be able to get around that, but exactly what is happening is sort of driven by the data source. And that again ties into that same push mechanism. If I tell you that I want you to do a create or I want you to do an update, then that tells the data consumer what is expected to happen in their persistence layer. You cannot process a transaction and say, yeah, you asked me to do an update, but I decided to not actually update that record because I don't feel like it. That's not a viable thing to do in a transaction. You have the ability to reject the entire thing, but you don't have that same flexibility as you do in the search response where, yeah, I don't really care about the addresses and I don't trust you as a source of address information anyhow. I only care about the date of birth and the gender, and I'm not going to actually store that as a patient record. I'm just going to store that in as part of my lab result because that's what's necessary in my environment. You have that greater flexibility. Sometimes you're going to be accessing data that already exists. Sometimes you're going to be accessing data that gets generated on the fly. So that average function is not referring to observations that already exist in the server that are being created as you're asking. You also have the ability to store information as a collection. So I'm sending you a discharge summary and I want you to store that as a package as opposed to as individual instances. Or sometimes this data is perfectly reasonable to access independently. And I want to be able to send different parts of it at different times, and I want to be able to update different parts at different times. And that's going to drive your packaging mechanism. Synchronous versus asynchronous. Sometimes there's going to be a delay, even if there aren't humans involved. There might be downstream systems that you need to access. There might need to be processing that has to happen. You might just be sending tons and tons and tons of data. And it's not reasonable to expect millisecond response time in terms of transmitting that or getting it back. So all of those are a subset of the decision points in the tree about what you need to think about. In terms of where this is going, the criteria and the list of approaches was subject to review by a bunch of different work groups within HL7, and it went to ballots this past September. We've got some feedback on the content, and we're working on incorporating that. We didn't get tons of feedback, so either that means that everybody was super happy and thought we got it right and it was totally awesome, which is possible, or not enough people were paying attention, which is perhaps more likely. So please do review and please do provide feedback. You can provide feedback on anything in HL7, or at least anything in the FHIR space by clicking at the bottom on the propose a change link, and tell us what you think we got wrong or what could be more clear or better expressed or whatever it is that you think would help. In terms of what Davinci will be doing with this, we will be referencing this decision tree in all of our implementation guides, saying this is the approach that we landed on, and here is why. Here's the path that we went through the tree, the choices that we made, the reason that we took the path that we did. And we certainly would encourage other implementation guides and other projects to do the same, because I think that's a nice thing for the implementer community. If there's sort of a consistent message to implementers of these are the options that we considered, and this is why we chose this particular approach, that then reinforces to them that it's not the Wild West out there, that there is some consistency in terms of how the design community is approaching what we're asking them to do. The work is there. Do explore. There's a lot of content. So if you sort of take it out of the web and turn it into a PDF or something like that, it's probably 60 odd pages worth of content to read. If you think that there's content there that is fluff and is not useful, let us know that. If you think that we're missing stuff, let us know that as well. In summary, there are a lot of different ways to share data in FHIR. The fact that you want to say, I'm using FHIR to share this is not sufficient. You have to get more fine-grained than that and explain how. Some of them are widely adopted and presumably therefore easier. And some of them maximize your chances to reuse an interface for multiple purposes. And so think about both of those things. And there is now some guidance to help you wade through all of the different possibilities. So do take a look at those. And the more we get people to follow the same guidelines in terms of what they want to take on, the more likely it is that we will get interoperability, because people will be using the same approaches to solve the same problems. So we've got a little bit of time for questions. And as always, you can reach me on Zulip or by email, and happy to talk about this or anything FHIR related.
Thank you, Lloyd. A great presentation and a serious issue to be addressed. We do have a few questions. One question is where to find the decision diagram. I pasted the answer in Whova in the answer to that question, so you can find it there or in the presentation of Lloyd, of course, when it's available. Another question is already.
I can also quickly show you where to find it. So if you are in the base FHIR specification and you go look for IGs published by affiliates, and you search for HRX, that gives you the HRX specification, and you can take a look at the continuous integration build, and it is under background approaches to exchanging FHIR data, and that's where you find the whole spec. Sorry, I interrupted you, Mark.
Yes, no, fine. This is what the people wanted to know. There's also another question, whether the data exchange patterns will be included explicitly in the FHIR spec website. So you more or less said that the diagram will be moving to R5 when it comes out.
The whole set of documentation that is in that section of the HRX implementation guide is intended to move into the core specification. So there will be a way to get to it from the homepage of the FHIR spec, and it is already pretty integrated with the FHIR spec in terms of links elsewhere, but we'll probably have more links to it from various places in the FHIR spec. So if you're in the search area of the FHIR spec, there will probably be a link from search into the decision tree so that you can find it from wherever it is that you're looking in the FHIR spec. We haven't landed that yet. And of course, all statements about what will be in R5 are tentative because it depends on how ballot goes.
Yes. Other questions are popping up. One interesting question is, of course, another option is to design and implement a completely custom solution for Exchange. Do you think there are situations where this might be a sensible choice?
There's situations where pretty much anything is a sensible choice. I mean, custom solutions allow you to optimize. And you get exactly what it is that you need for a particular space. But you typically don't get the ability to reuse that anywhere else. And you're faced with the cost of anybody who's trying to tie into that space of needing to pay for completely custom development. And so what typically happens is a completely custom solution may be faster and cheaper the first time around, but it's going to cost significantly more long term. And it may be harder to get people to play because they generally want to create a small number of interfaces that work with lots of partners rather than creating separate interfaces for each partner. But there will absolutely be situations where FHIR is not a very good fit, or where in the space you're trying to get interoperability happening, there is just zero interest in taking on FHIR. Maybe they're tied to a legacy technology and JSON and XML are too scary, or maybe they've embraced something completely new and XML and JSON are way too old hat, and nobody wants to touch those. There's lots of reasons that could drive you to something else, but there's good reason why standards take off and are popular.
Yes, you told us that in Davinci you are using the decision tree as a rationale for why you've chosen a certain approach. But if you start using the decision tree, don't you risk that you end up with all the 20 architectural patterns in the end?
Only if we have use cases that cause us to land in all 20 places, which is unlikely, but possible, I guess. In the end, you're going to be driven to the solution that your use case dictates. And there are some use cases where push makes sense. There are other use cases where pull makes sense. And you're driven by what the requirements for the underlying exchange are. So the decision tree is more about helping you to make sure that you've identified accurately what all the considerations for your use case, what underpins your use case, and guides you in terms of, based on your particular set of requirements, this is probably the one that makes the most sense. In the end, Davinci, like everything else, is going to be driven by the implementer community. So if the decision tree says you probably want to use, say, CDS hooks, and the community says, no, nobody in our space wants to implement CDS hooks, that's too scary or whatever, we want a custom operation, then that's how we will go. But we would then say the decision tree said X, the community said Y, and we've decided to listen to the community, and that would be part of our documentation about what's going on.
Yes, there are a couple of very concrete questions. So to pick one of those, which approach would be suitable to connect two larger hospitals to search for patient information within the FHIR servers of both hospitals at the same time?
hard to come up with a single answer to that without probing a whole lot more about what's possible. The short answer is that there's probably multiple viable options. Does the search need to happen real time? Do you have an intermediary who can act as a sort of black box interface, or do you need to hit both of them? Do the search results need to be interpolated? There's a whole bunch of things to think about. And the decision tree doesn't get into that level of sophisticated architecture. So it talks about what do you need for a particular exchange. It does not talk about how do you combine 2 or 5 or 15 different systems with different capabilities into one. We may take that on at some point too, but this was more about these are the foundational technologies. So, I mean, even if you say we're going to do RESTful query, you can have a whole lot of variations about how that actually gets implemented behind the scenes, where you've got multiple repositories and are trying to merge tables from different databases and all that kind of thing. This specification does not get into that level of architectural guidance.
Well, thank you, Lloyd. We're running out of time. There are 2 more questions in the question and answers, but we'll be looking and answering them in the Whova app. And thanks again for a great presentation. I'm quite certain that the work that's being done with the decision tree in Davinci is going to help a lot of people in this really difficult area. So thanks.
Thank you. Bye all.